So this is my, okay, so 702, this is your video. Let's just get started. The spinner spun, and spinner number 1 through 8 spun 3 times. Each time the spinner number landed on a prime number. What's the probability that it will land on a composite number next row? So let's do this spinner. What is this? Got 8. 1, 2, 3, 4, 5, 6, 7, 8. So my prime numbers are 2, 3, 5, and 7. My compositive numbers are 4, 6, and 8. One is neither prime or composite, so it landed on a prime number. Let's just, I don't know, make it up. First 3 times. So it landed on 2, and then on 3, and then on 5, right? The first 3 times. I'm asking you what's the probability of landing on a compositive number here. All the previous rows really don't have any effect here, right? So it's going to be chances of landing on a composite number. 3 out of how many? 8. Two. Without replacement, the bag has 3 yellow, 5 blue, and 3 marbles. So you're going to take 1 out at a time. And you're not going to put the marble back. It says without replacement. So you're not going to replace it. So you just take it out and leave it out. So what's the probability of selecting the yellow? So we want probability of yellow. And follow a yellow. So what's the probability? You put your hand in the bag, take a yellow, put it on the side, go back in the bag, take another yellow. So we need to find the total first. So there's 3, 5, 8 plus 3, so there's 11 total. The probability of getting 11. A yellow on the first one is 3 out of 11. If you take 1 out and leave it on the side, the second time you put your hand in the bag, there's going to be 10 in the bag. And also there's going to be 1 less yellow. You can change that to 1/5 if you so choose. 3 times 1 is 3, and 11 times 5 is 55. So you have a 3 out of 55 chance of accomplishing that. Not too many, not too much of good odds here. So now this one says with replacement, so it has 4 pink, 5 black, 2 white. What's the probability of selecting a pink followed by a black marble? Okay, so with replacement, so once you take a marble out of the bag, you're putting it back inside and starting all over again. So we want the probability of what? Pink followed by a marble with replacement. Like black one, right? So the probability, let's find the total first of all. 4, 5 is 9 plus 2 is still 11. Probability of getting a pink is 4 out of 11. So you take a pink out, put it back. Now there's still 11 in the bag, and you want a probability of getting a black one, which is 2. 8 out of 121. Okay. Wow, that's even worse odds. 4. Table below shows the result of picking the marble from a bag with replacement. So you're taking one from the bag and you're putting it back. What's the probability of picking a red marble on the next turn based on the experiment? So there's 1 red, 1 yellow, 1 blue, right? So there's 3 marbles in the bag, and I should have written that somewhere. So there's 3 marbles in the bag. You're taking 1 out, put it back, taking another 1 out, put it back, and you're doing this experiment. And you just did an experiment, and you did this for 30 trials. And out of the 30 trials, these were your results. 10 were red, 14 were yellow, and 6 were blue. So based on this information, probability of picking the red on my next try, well, based on the experiment, would be 10 out of 30. So I have a 1/3 chance of happening based on the experiment. Okay. Which is very close to the theoretical, right? Which is 1/3. You're waking up in... What's the probability of picking a number greater than 2 on a die? So a die has 6 numbers. 1, 2, 3, 4, 5, 6. Greater than 2? What's the probability of you rolling a die and getting those numbers? Unlikely? No. Likely? Yes. Certain? Not for sure. Impossible? Definitely no. So definitely likely, because there is a 4 out of 6 chance, or 2/3, or 66.67%. So likely, I would have chosen likely, right? More than 50% chance. Between likely, between 50 and 100, 66.0. Yeah, it's definitely likely. I don't think I explained that too well. Next one. What's the table below? What table? The table below shows the different types of books, different types of books sold. Based on the data, what's the probability that the next book sold will be a physics book? Well, you always have to find a total first, right? So let's add these numbers. So we got 44 plus 36 plus 24 plus 25. There were a total of 129 books sold, right? And if the next person comes into this, I don't know, bookstore, what is the probability that the next book will be a physics book? It will be a 25 chance out of 129. So the probability that the next physics books, the next book is a physics book. Why can't I say that? Based on this, right, the experiment being the sales of the previous 129 books that were sold in the store, there's this much chance, and you can change that to a decimal and then to a percent if that's what the question. But if it's a fraction, the probability of that happening is 25 over 129 based on the experiment. The table below shows the result of an experiment. Based on data, how many times would you expect the spinner to land on 6 in the next 300 spins? Well, let's see how many times this was spun. The number 1 came out 8 times, the number 2 came out 6 times, number 3 came out 9 times, the number 4 came out 11 times, number 5 came out 9 times, and the number 6 came out 7 times. So let's see how many. We got to figure out this particular. So how many times was this experiment? This experiment was 8 plus 6, which is 14, plus 9, which is 23, plus 11 is 34, and then 34 and 6. So this was an experiment. They spun a spinner 50 times, and these were the results, right? So I'm concerned it was a number 6. So number 6 came out 7 out of 50 times in this experiment, right? So they spun the spinner, and 7 times it came out 6. So based on the experiment, 7 times out of 50, and I don't know why I wrote it like this, would be the experimental probability of landing on the 6, right? The experimental probability of landing on the 6 is 7 out of 50. And if I use that to predict what's going to happen in the next 300 spins, I can multiply that by 300. Let's simplify here. This is 1 and 6, and that's going to give us 42. So based on this experiment, I expect that on the next 300 spins, 42 of them will land on 6. Number 8. Use a table below to answer which class has the higher median, and greater math. You're kidding me. Okay. So I'm going to write class A. Jesus, 31, 31, 32, 33. I should put commas. 33, 2 34s. 2 35s, 36, 3 times, 38 2 times, 39 1 time. Jeez. Whose idea was this? The next one, class city B, is 33, 34 2 times, 35 2 times, 36 4 times. 1, 2, 3, 4. 37 2 times, 38 2 times, and 39. Remind me not to give you this problem. High, medium. So the median here. Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The median for this one is 35. The median for this one is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the median is 36. So the median, I'm going to put city B. Mean, well, we got to add all those up. Does the calculator take all these numbers? How you got it? Plus 33 plus 68 plus 70 and just plus 72 plus 36 plus 76 plus 39 equals 488. So it's 488 divided by how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Divided by 14. So the mean here was 34.86 rounded. And the mean over here is going to be 33. Hopefully I'm doing this right. 33 plus 68 plus 70 plus 72 plus 72 again plus 74 plus 76 plus 39. That's going to give us 504 over here divided by 14. So the mean here is going to be 36. Okay. So let me write, that's the median. This is the median. And then the mean here was 34.86. And the mean here was 36. So now, I think this one is yours. Let me do the math for this one. Right, so divided by 14 again. So I have to subtract 36 minus all these numbers. So it's going to be, and you can, so it's 3, 2, 2, 1, 1, 0, 0, 0, 0, 1, 1, 2, 2, 3, right? The distance between these numbers and 36. So 33 is 3 units away from 36, 34 is 2 units, 39 is 3 units, and so forth. So now we got to add these two. So 3, 2 is 5, 7, 8, 9, 10, 11, 12, 13, 13, and 5 is 18. So if I add all these, I get 18 divided by 14, and that's going to give us that their average distance, or 1.29. 1.29. So that's my math. What am I writing? That's the math. So the mean absolute deviation here is 1.29. So this one, I have to subtract 34 or find the difference between each of these values and 34.86. So let me write them down. So it's going to be 3.86, 3.86, 2.86, 1.86, 0.86, 0.86, 0.14, 0.14, 1.14, 3 times, and then 38 is going to be 38, 3.14, 3.14, and then 39 is going to be 4.14. So there's all the distance. So I'm going to add all these distances from the mean and then divide them by 14 as well. Okay, that's 3.86 plus 3.86 plus 2.86 plus 1.86 plus 0.86 plus 0.86 plus 28, 0.28, I'm just, 28 plus, what is that? 3.42 plus, I have to do all these again. So 3.86 plus 3.86. 3.86 plus 3.86. Okay, I can't use a calculator. Plus 3.86 plus 2.86 plus 1.86 plus 0.86 plus 0.86 plus 0.14 plus 0.14 equals, I'm just going to write this up to here, it's 14.44. Now let me add that, 14.44 plus 1.14 plus 1.14 again, plus 3.14 plus 3.14 and plus 5.14, and that's going to give us 28.14, which I'm going to add to 14.44, and that's going to give us 42.58. So that's all their distance added, divided at 14, and the mad is 3.04. That's my mad. So you can tell definitely that even from the picture that what was the mean here? 36. The mean here is 36. Here was the mean. That a lot of the numbers were close to the mean as opposed to the top one where the mean was 34. The mean was 34 right here. Right? That was the mean for city A, and you can see that a lot of the data points here are further away to the mean than city B, where everybody's sort of more bunched together. Okay, and that's that for that problem. 9. Hopefully I didn't give you another problem like that. So this one says compare the MAD for both groups. Okay, so this one, thank God, has lesser numbers. 90 plus 95 plus 88 plus 100 plus 98 equals, so this is, the mean here is 471. I'll write that the mean is 471. And the mean for the drama class, 115 plus 120 plus 150 plus 135 plus 134 equals, and the mean here is 664. So the drama movies are a little, I have to divide this by 5, which I didn't. And that is 132, an average 132 minutes, and this one divided by 5, 471 divided by 5 gives me 94 minutes and 20 and 1 and a quarter, right? Not 1/5. And 12 minutes. So this is the average, and then we want to find the MAD. Obviously, we have to subtract 94.2 minus this minus this, and find the MAD. So to find the MAD, let's subtract 94.2 minus 90 is 4.2, and this is going to be 0.8, and then plus 2, 6.2, and then plus 5.8, and then plus 5, 3.8. Divide that by 5, and we get that our MAD is, I have no idea, 4.2 plus 0.8 plus 6.2 plus 5.8 plus 3.8 equals 20.8 divided by 5. So 20.8 divided by 5 is going to give us that our MAD is 4.16. So, and let's see if the drama, all the movies, their times are a little bit more bunched up together. So the MAD, this is MAD, MAD, we got to find a difference that each of these points is away from 132.8. So 115 minus 132.8 equals 17.8. So it's going to be 17.8 plus 120, that's going to be 12.8. Next one equals going to be 17.2, and then it's going to be 3.2 plus 3.2, and the last one is going to be 3.2, and the last one is going to be 11.2. So let's add that up. 17.8 plus 12.8 plus 17.2 plus 3.2 plus 11.2. That equals 66 0.2, and we're going to divide that by 5, and it's 12.44. So definitely the math is much bigger here, so which means that the movies are, that the drama movies are not all together. Their timing, they're like more, they go away from each other. They don't have similar times, right? So they're further away from the mean than the comedy. So if you look at the comedy, all the numbers are a little bit closer to each other, or closer at least to 94.2, whereas they're not with the drama. Okay. Number 10. No. Draw a tree diagram. Okay, I can do this. But I'm going to use symbol. So I can get a chocolate ice cream. So this is going to be the cones. And this is going to be the flavors that I can get. And this is going to be the top. So I can get a chocolate cone. Sorry, not chocolate cone. There's no chocolate cone here. What am I doing? So I can get a sugar cone. So there's two types of cones I can get. I can get a sugar cone, or I can get a plain cone. With my sugar cone, I can get a chocolate, or a vanilla, or a strawberry ice cream. But with the chocolate, I can get a sprinkles, I can come with fudge, and I can have it with nuts. With the vanilla ice cream, same thing. Sprinkles, fudge, nuts, and then with the strawberry ice cream, I can get sprinkles, fudge, and nuts. So if I put my sample space over here, I can get SCS, which is sugar, chocolate, and sprinkles, or SCF, SCN, and then I can get SVS, SVF, SVN, and then I can get sprinkle, and no, sugar, strawberry with sprinkles, sugar, strawberry with fudge, and I can get sugar, strawberry with nuts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Really? 1, 2, 3, 4, 5, 6. Yeah. So I can get 9 types of ice creams with the 9 types of different combinations just with a sugar cone. And obviously I'm going to get, and fine, I'll do it, the same exact thing with the plain cone. I can get chocolate ice cream, vanilla, or strawberry. In which of these 3 I'm going to get 3 different toppings, which is going to be the sprinkles, the fudge, and the nuts, the sprinkle, the fudge, and the nuts, the sprinkle, the fudge, and the nuts. And I'm going to write all that over here. PCS, PCF, PCN, PVS, P vanilla fudge, plain vanilla nuts, plain strawberry sprinkles, plain strawberry fudge, plain strawberry nuts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So a total obviously 9, and 9 I can get 18 different combinations, all the possible outcomes. Okay, so I definitely will need to see all that in your test. Number 11, Miss Bryan selected 18 out of 350 students in the 6th grade to go to the museum. If Miss Toy decides to select 7th grade students based on the same probability that Miss Bryan used, how many of the 450 7th grade students will go to the movie? So in the 6th grade, the probability of you being selected was 18 out of 350, right? So if we use that, and if Miss Toy uses that same, ratio there, we're going to multiply that by 450 to see how many of the 450 students in the 7th grade will be selected. Well, let's simplify things over here. Divided by 5 is 7, divided by 5 is 9. I can then multiply 18 times, it's 8 multiplicado por 9 equals 162, and we're going to divide that by 7, and Ms. Choi can select 23.14 students, because Since that can't happen, it's going to be 24 students. Okay. 12. What is this? Same. The table below shows the number of books sold at the bookstore based on the data. How many zoology books should be ordered? I don't know how I write these things. Should be ordered in the next order of 400 books. So again, let's add this up. 44 plus 36 plus 24 plus 25. It means that 129 books were sold. So based on these sales, how many zoology books should I buy to restock? So it's zoology books was 24 out of 129, right? So based on this, if I order 400 books, how many of those should be zoology books? Big hit, by the way. 24 times 400 equals 9,600. Divide that by 129. That means that my next order is 74.41. 74.41 books out of 400 should be zoology books? Yeah, so I can't order 74.41. Let's just make it 75 books. So my next order, the 400 books, 75 of them should be zoology. Use the data use the data below for well, that's the higher median. Well, the median is this one, right? Here, the higher median is store B, right? About 51. So the interquartile range is Q1 minus Q3. Remember, it's this point minus this point. Which it looks like it's 55 minus 30. So the IQR here is 25. And the IQR here is 65, right? This point right here. Minus this one, 65. And let's just make that, well, if this is 45, this should be about 48. Let's just say make it 48. 65 minus 40. 17. So, I mean, clearly you can tell the higher IQR is interquartile range is this one, right? And then the second part, which store had 75% of the sales above 50? Well, 75%. So remember, each of these parts is 25%, right? That's 25%. So which of these stores has 75% sales above 50 wristbands sold daily? Well, above 50 would be this part right here. So which store had above? So definitely store B, because you had 25% here, another 25% here, and another 25% here. So 75% of their sales were 50 wristbands or more. So, right, and definitely not on that one, on store A. 14. Which tree diagram correctly shows the outcome of a two-question true or false multiple choice quiz? So if you had two questions, right? So question 1, you can get true. Question 2, you can either get a true answer or false answer, right? Or on question 1, you decide to select false. And question 2, you can get true. And question 2, you can also get false. So all the possibilities of views. So you can answer the test as having two true and true. Question 1 is true. Question 2 is true. Or you can have question 1 is true. Question 2 is false. Or you can also have question 1 was false, which makes question 2 true. And you can have a false. So there are 4 different possibilities if you had a quiz with 2 questions and it was a true-false question. Right? And the one that looks like this, so true, false, false, true, 4 different what do you call we got 4 different outcomes. Looks like well, all of them on question 1 are correct, right? True, false, true, false, true, false, true, false. And every single one of them should have true, false, true, false. This one, true, false, true, false, false, true, false, false. Hang on a second. Well, definitely not this one because they're missing this part, right? So this buddy's gone. So this one, question 1 was true. Question 2, what should have been true, true. Sorry, true, false. So this one's gone. And this one, what's wrong with this one? True. And then they can answer true in the second question or false. And false, true, false. That looks okay. And this one starts. So in question 1, I can answer as true. Oh yeah, because this says question 1, right? The first one says this first one should be how you answer question 1, and this second column should represent how you answer question 2. So this is the correct tree diagram. Okay, so not bad, actually pretty easy. That's it.